Hello, everyone. Welcome to day 4. It's a bit of a long one to read, but I promise you that it's not super complicated. So I'll give you a big summary. Essentially, the elves are now trying to figure out who gets to clean what parts of the camp after their long excursion. Everyone gets a set of unique IDs that are the areas that they clean, so they'll get like a 2 to 4. And then their partner has another set. So it's a set of 2 elves, cleaning some area. And we'll get this as our input file. Now, just to visualize it a little bit better, this is what it looks like as the file. So we're going to have some sort of like pair of pairs, if that makes sense. Now, what we want to do is figure out which set of pairs has one fully encapsulating the other. So in this first example, we see that 2 to 4 is within 6 to 8. So this first elf is doing all the cleaning that the second elf would do anyways. So what's the point of having it there? We might as well just delegate this person somewhere else. Why clean the same thing twice? So the question for today is pretty simple. In how many assignment pairs does one range fully contain the other? So we're looking for a completely closed set. Now, a good point to make right here, we have this case. Which one is it? This one. So 6, 6, and 4, 6. 6, 6 is within 4, 5, 6. So we're not looking for things that are fully within. So if it was just within, then it would just be 5 for this set. We want to know if it's the edges as well. We want, not going to pull up the Paint Studio for this one, but we want the closed bound kind of situation. So when we say 4 to 6, we mean 4, 5, and 6. Those are the ones we want to check. It's a little bit of a distinction to make, but it's a very important one that we have in this set of examples. Otherwise, we would be doing the wrong code. So this is a very simple solution. We're going to go through it really quickly today. I don't think it'll take too long. I'm just going to upload it and get it out of the way. Hopefully, this solution is the one that you got. But if you are kind of just following along, let's think it out. So if we've got a set, that is contained in another set, let's say this one right here. We've got 2 to 8 and 3 to 7. What we can check is if this number, the first number, the smaller of the two, is bigger than the other one, whichever way it goes, first or second. And then if the same thing is true on the opposite end, so if this number is smaller than this number, then it's contained inside. Now, I did say that we're using the closed bound, so it'll be if this number is smaller than or equal to this number, and if this number is greater than or equal to this number. Left side is equal to line.split, and on the right side to the same thing. So now we could split it again, but we can also just do the splits in line. So I think I'll do that just to save some space and save some time. So we can say if left side dot split on the dash character at 0 is it greater than or equal to right side dot split. In this case, that means that the left side value may be within the right side. We've got at least one bound that works. And we'll just put a pass in here for now. Now the other half of it is, let's just actually take all this and just flip the sign. So that covers the case where there might be a collision, or there is some sort of collision potential. So now we're talking about right side, so we'll say if right side dot split. You know what, let's just copy this line because we're going to be using this a lot in some sort of variation. Right side dot split, flip this to the 1, so now we're checking the right bound. If that is less than or equal to left side, let's just flip that, and then left side dot split on the 1th. Now, if that's the case, then we want to increment some sort of counter that keeps track of the number of lines that this happens. So let's just have a rolling sum, or rolling counter in this case. Rolling counter equals 0. And if this happens, then we just want to say rolling counter plus equals 1. And now we just have to do the same thing, but in reverse for the left side case. Let's print out rolling sum. Now, if you were in a production environment, you would probably just return rolling counter, but we're doing Advent of code, so it's just going to be printed to the screen. Let's change our directory to day 04, and then do a Python solution.py. Oh, whoops, Python 3. 530 overlaps. So over half of them have one elf completely inside the other one. They're cleaning the same spots. That doesn't seem very efficient. Well, let's just double check first before I start slandering the elves. Ah, the answer is too high. Curiously, it's the right answer for someone else. I guess that's cool. So I'm not seeing where our algorithm is breaking unless the total overlap case should fail. And I don't think they really have an example of that on the web page. So it does make sense that we would have to screen some of them out. So let's try screening out the equal cases. So if we wanted to get rid of the equal cases, then we want to check before we get into here. If we said, let's say, if left side is equal to right side, let's make that the not case. So not equal to right side, then we can increment rolling counter. And we'll do the same thing down here. You know what, we could actually just come up here and say, if left side equals right side, continue. And we'll just go back around for the next loop. There we go. So let's try that. 484, okay. So that is smaller. Let's see if that's the right answer. Too low. Aha. All right. Well, I'm a little stuck. I'll keep playing with this. Maybe I'll check out the subreddit for this one because it seems like maybe I'm missing a case. Maybe throw it in the comments if you can think of it. I'm pretty sure we covered all the cases with this, and we do have this here just in case, you know, a perfect overlap is not valid. Yeah, I'm at a bit of a loss. I thought this was going to be an easy one, but it looks like day 4 has stumped me. So let me know if you have any ideas, and maybe the subreddit will have the answer. Just a bit of a short video today, and we'll see where we go tomorrow.